A depolarizing triggering event brings the membrane to the threshold potential of minus 50 millivolts. At this time, the voltage-gated sodium channels open. Sodium moves down its concentration and electrical gradients into the cell, carrying its positive charge with it. Inward movement of sodium leaves behind the negative charges with which the sodium had been paired. The membrane becomes increasingly depolarized as the inside of the cell becomes less negative and the outside less positive. Further movement of sodium inward neutralizes even more charges on the inside of the cell, progressively decreasing the internal negativity until 0 millivolts is reached. Continued inward movement of sodium reverses the potential, with the inside becoming positive as the action potential peaks. At the peak of the action potential, the sodium inactivation gates close and the potassium gates open. Potassium flows down its electrical and concentration gradients out of the cell. This leaves behind negative charges with which potassium had been paired inside the cell and neutralizes the negative charges outside. Membrane potential drops to 0 millivolts. Continued outward movement of potassium restores the resting potential. At resting potential, the sodium inactivation gates open and the activation gates close. Further outward movement of potassium transiently hyperpolarizes the membrane. Then the potassium gates close and the membrane returns to resting potential.